Section 4.4 deals with two different but related ways of addressing data in memory. And Section 4.5 deals with two big instructions, the jump and the loop. Let's take a look. Let's go over the ways of addressing first. Starting with indirect addressing, let's declare an array of byte-sized data. We'll call it nums. Here's what it looks like in RAM. Now if I do this instruction, I'm moving the address of nums into the ESI register. And then I add this instruction which says go to where ESI is pointing and load that byte value into AH. So the AH register contains 250. Then I update the ESI register. Notice what I'm adding. Nums is of type byte, so it's going to add 1 to it, which means now ESI is pointing to the 75. And when I move that into AH, now AH contains 75. Now sometimes I might have to write the code like this because the assembler can get confused. If it just sees ESI as a pointer, it doesn't know whether it's pointing to a byte or a word or a double word. So sometimes you have to spell it out for it by putting byte pointer or word pointer or D-word pointer, something like that. And there's nothing special about ESI here. We could have used any general purpose register. Now let's take a look at indexed addressing. I've got my same array as I had before. It looks the same in RAM, and this time I'm going to try a little something different. This time I'm sticking a 0 into the ESI register. The reason they call this indexed addressing is because we're using a register as an index. Notice the syntax here. This says go to where nums is, go ESI bytes past that. Well, since ESI has a 0, we're just looking at the first thing in nums. We're moving that into the AH register. I'm adding 1 to the ESI register now, which means it contains 1. When I do this, it says go to nums, then go ESI bytes past that. Well, since ESI has 1, it goes to what we would call the 1 index in a high-level language and loads that into AH. So now AH contains the 75. Which brings us to these two very important instructions. Let's look at the jump instruction first. Say I've got this code. Nothing special about it. I'm moving 24 into the EAX register and then adding 1,000. This code does nothing at all. But what I want to point out is over here on the left, I've got a label. And since it's in the code section, the colon has to be there with it. Now I might want to put an instruction like move 7 into the DH register. You can put it on the same line as the label, but sometimes that makes your code hard to read, so sometimes it's better to move it down a line. That label is going to have the same effect either way. So let's throw some more code in, and down at the bottom of it, I've got the jump instruction. And notice what it's saying. It's saying jump to the label JP1, which means it'll jump to here and execute that moving 7 into DH again. Now look at what we've got here. There's nothing obviously changing inside this, which means I've created an infinite loop unless somewhere down in here there's something that'll jump someplace else. Speaking of loops, let's take a look at one. The whole loop instruction is based on using the ECX register as a counter. So if I want the loop to execute 6 times, I've got to put a 6 into the ECX register, and that's got to be done before the loop. I'm just moving a value into EAX, and I put a label out here again. Again, there's nothing special about the name of the label. You want them to be kind of explanatory. And again, the colon has to be there because it's in the code section. I put some more instructions in. I get to the end of the loop, and it's going to jump back to the LP1 label. Each time I get to that loop instruction, the ECX register decreases by 1. After it goes through the loop 6 times, adding 100 each time, then EAX contains 600. Really important to remember, don't change the ECX register inside the loop. You probably won't be happy with the results. You've actually been using pointers without realizing it, but let's look at it in a little more detail. Suppose I have an array of words and then just a byte declared in our data section. I can do this and say value PTR, and there's nothing special about that name. When I put the D word and then values, that says store the address of values into value pointer. I can do the same thing with age, and it'll store the address of that 24, in other words. Now, how do I use them? That's the question. Well, here's what all of that data looks like in RAM. Value pointer is pointing to the first element of the word array. Notice the little Indian way of storing there. And age pointer is pointing to that 24. The 18H is the same as 24. I might think I can do this, but I can't, because the only thing I can put in the brackets is a register or a literal number. So this value pointer isn't going to work. You won't get the results that you want that way. Here's what I have to do. I've got to move the address stored in value pointer into a register. And then to move that into the AX register, for instance, I can put the ESI in brackets, and then I have to probably tell the assembler, oh, it's pointing at a word. Remember, the assembler has to know what size data it's pointing to. So if I try and do something similar to load that 24, the 18 hex, in age into a register, here's what I've got to do. Remember, the pointer is a double word value. I can load that into EBX. But to load the 24 into the DH register, for instance, I've got to tell the assembler, oh, we're pointing at a byte. That about wraps it up for sections 4.4 and 4.5. If you have any questions at all, please get with me. And once again, thanks for watching.